Welcome back to OCR MEI Further Mathematics B. Today we're doing chapter 3.9, Plane Line Intersections. So when we work with a line and a plane, we often deal with the angle of intersection, which has something to do with dot product again. And we also would like to find the coordinate of the intersection, because a point and a plane and a line intersects at a single point. So the aim is to find the coordinate of that single point. So example is to find the angle and intersection between the vector plane x take 2y plus z equals 0 and the vector line r equals to 1, 3, 2 plus lambda 2 minus 1, 1. So first of all, we want to find the Cartesian equivalent of the vector line. So let's get that started. So r can be written as a vector form x, y, z is equal to 1, 3, 2 plus 2 lots of lambda minus 1 lots of lambda, 1 lambda, and we can just do this vector sum. So we can have three equations where x is 1 plus 2 lambda, y is 3 take lambda, and z is 2 plus lambda. With these equations set, we can now substitute into the equation, the plane equation. So let's do that to find lambda. So if 1 plus 2 lambda, take away 2 lots of 3, that's 6. Take away a negative 2 negative lambdas is a plus 2 lambda. Then add a z, which is just 2 plus lambda equals to 0. Now we collect like terms, so we've got 1 plus 2 is 3, take 6 is minus 3, then 2 plus 2 plus 1 give us 5 lambda, and that equals to 0. Now we can rearrange everything to find that lambda equals to 3 on 5, and that would be a very important value to obtain. Now to find the actual intersection point, we substitute the lambda value into this r equation, and that essentially we can substitute into these three subforms, and that should give you something along the lines of 11 on 5, 12 on 5, and 13 on 5 as the three values. So x is 11 on 5, y is 12 on 5, and z is 13 on 5. That concludes the intersection bit, and now we want to find the angle. To find the angle, you want to find the vector plane normal, which can be straight up read as 1 minus 2 and 1. And we know the directional vector is 2 minus 1 plus 1. With these values, we can now do a dot product. So to carry out a dot product, we recall that cosine of theta equals to the dot product, which is 1 times 2 plus minus 2 times minus 1 plus 1 times 1 equals to 5. So we've got 5 on top of the modulus of the multiple of the two modulus. So the first one is modulus 1 squared plus minus 2 squared plus 1 squared, or root is root 6, multiplied by the bottom, which is also root 6, and that would result in a 5 on 6 equals to cos theta. And we can use this to find that theta is actually equal to 33.6 degrees. So that would be the end of the example. So it's important to be able to confidently convert the line equation from vector form to Cartesian form. And as well as remember, when you do the dot product, you need to divide by the modulus of the vector, and I've seen a lot of people just completely forgot about it, and that would not be nice, because then you will not be able to do your arc cosine function, and you'll get math error on your calculator, which is not good feelings during an exam situation. So, question time. I've made 2 questions for you. Find the angle and intersection of the line and plane below. And as usual, I'll give you 5 seconds to do these questions. Pause the video, of course. So I'll show you the answer in 5, 4, 3, 2, 1. There we go. The answer is shown here. For the angles, it can be either obtuse or acute. Both of them are accepted in this case because the question deliberately wrote find the angle rather than find the acute angle. Again, take note on that, because this will slip a lot of people up. But other than that, this will be the end of the video. I hope you've enjoyed. If you have any questions that you want to ask, do leave it in the comment section below, and I will see you on my next one.